Hello and welcome to another lesson in the Advanced C# course brought to you by Tuts Plus. Now this lesson I'm going to dig into one of the deep and dark corners of the C# language, and that is reflection. Now you can think of reflection very similarly to how you view your own reflection. When you wake up in the morning and go into the bathroom and you look at yourself in the mirror, you see a reflection. You see things that make up yourself, the characteristics of yourself, your face, your eyes, your ears, your nose, your mouth, arms and legs, and all those things that make you, you. Well, reflection within the C# language does exactly the same thing. It allows your code or your assembly to look within itself and take a look at and inspect those characteristics that make it itself. Now, it's kind of interesting when I first began learning about reflection. It's one of those topics where I kind of felt like this is a really cool parlor trick, but it doesn't really serve much of a purpose for me. And that was the case for a while, but as I started to play around with it more, I saw that it was very powerful, in fact. But like anything else, with great power comes great responsibility, and that if you misuse it, it's definitely going to be to the detriment of the performance of your software. So let's go ahead and jump into some code. I'm going to show you a little bit about reflection, how to use it, what it can do for you, and one of the nice little sweet spots that allows you to use it to make your code very dynamic. So here we are back in Visual Studio, and I'm going to start like I normally do, creating a new project, a console application, and click OK. So now here we are within our code, within our main method of our class program, or better yet, our type program, within our console application 16 assembly. And that's ultimately what's going to be created for us by Visual Studio and the compiler. When we build this, it's going to create that .exe for us. And we're not limited to doing reflection within console applications or exe files. We could also do them in class libraries in the .dll files as well. But for this case, we're going to run it through this console application to show you what I'm talking about. So the first thing you need when you're talking about reflection is you actually need an assembly to reflect upon or to inspect. So let's do that first. So I'm going to create a new variable, and I'm going to call it assembly. And now I need to set that to an assembly. So the simplest way to do that is to use the assembly class, which is found within the system.reflection namespace. So I'm going to add that to my file, and then I'll call the method getExecutingAssembly, which, as you would probably expect, gets all the assembly information about the current executing assembly. So in our case, that's console application 16. So now that I have that, what's the most logical thing for me to do first? Well, that would be to write out some data to the console so I can show you that I actually have it. So let's do a console write line, and we'll do assembly.fullName. So I'm going to go ahead and do Control F5 to run this. And you see something rather interesting here. You're going to see a very long string with a little bit more information than you probably had bargained for. And what this is the fully qualified name of your assembly, which is made up of 4 parts. The name of your assembly, which in this case is console application 16. The current version of that assembly, which by default is 1.0.0.0, and you can update that within your code if you'd like to, but for our case, we're just going to leave it that for each version, for each build of our application, and then the culture and the public key token. Now, some of these topics are definitely beyond the scope of this lesson, but just understand that these 4 things put together can uniquely identify your assembly, and these things are very important once you get into topics like strongly typed assemblies or assemblies that are loaded into the global assembly cache, which is a little bit beyond the scope of this lesson. So let's go ahead and dig back into our code and see what other things we can figure out about our assembly. So right now we have the name, and that's pretty cool, but what else can we do? Well, I alluded and started to talk a little bit in the previous lesson about getting the types out of your assembly. And what are types? At the end of the day, they're really just classes. So let's jump back into that one again. So let's say var types is equal to assembly, and there's a lot of really nice helper methods and properties in here, and I'll leave some of them for you to kind of play around with yourself, because once again, that's the best way to learn. I'm just going to give you some of the more common ones that you can work with. So in this case, I want to run get types. So now I have a collection of types that I can go ahead and loop through in a for each statement, and I will say var type in types, and I'll just write the name out, and I'll do a little bit of formatting here so we can see things a little bit easier, and we'll say type dot name. So I'll go ahead and run that, Control F5. So now I'm seeing within my assembly, I'm finding one type, which of course makes sense because I only have one class in here called program. Well, program is a little boring, so I'm going to beef this assembly up a little bit, and I'm going to add in one more class. So we'll call it public class sample, and we'll throw a few things in here just to make it interesting. So I'll create a property, it'll be a string, and we'll call it name, and I'll create a field, and this one will be an integer, and we'll call it age, and we'll create one method here just to round things off. It'll be a void, we'll call it my method, no arguments, and it's really not going to do anything for now. So we'll do a save, Control F5, and now you're going to see two types found within my assembly, which is exactly what I would expect. I have two classes, which equate to two types, program and sample. All right, well, that's not too bad, but what can I do with these types now that I have them? Well, you can do an absolute ton. So if you just kind of peek into some of the IntelliSense here, there's an awful lot of helper methods in here. Once again, I'm going to leave a lot of these for you to play around with, and they're very self-explanatory, surprisingly enough, for as complicated as the topic of reflection can be. But once again, I'm going to show you a few of them on here that are very useful when you're getting started and learning about reflection. So if you just take a look at our type down here, our class, I see a property, a field, and a method. So let's see if we can start using reflection, digging into our assembly and types to find these things and print them out to the console. And we can do just that. So first we're going to start with finding our properties, and we'll set that equal to type, which is the current type that we're looping through, and we want to get properties. And so now I have a collection of those properties within my variable, and I can once again for each through those, and I can say for prop in props, and I can once again console writeline prop.name. And we'll preface this with some formatting as well, just to make things a little bit more clear. We'll do a tab, and we'll say property, and concatenate. There we go, Control F5. So now we can see within our sample type, within our sample class, we have a property called name. And if you really wanted to dig in a little bit further, you could even tell the console here to write out what the particular type of that property is. So you could say property type plus prop dot property type. And I have to remember to concatenate this with a plus sign, Control F5. And as you can see here, we have a property whose name is name and the type is system.string. So now what do we have? So we have our property in here. How about fields? Well, we do that in the exact same way. And I hope you're starting to see a trend here, because doing this type of thing is very common across all the different characteristics of your code, whether it's properties, fields, methods, events, or whatever you're trying to work with. So I can say type.getFields, and I can go ahead and for each through those once again, field, fields, and we'll just write the name out to the console, field.name. Control F5, so now we have a field and its name is age. All right, well that's pretty simple. And let's just round it off. Since I know I have a method in here, we'll do the same thing for methods. Var methods equal to type, and as you can imagine, there is a get methods method. And we'll once again loop through those, method in methods, and we'll console writeline method.name. So there we go. Now this is a little bit more interesting. If you take a look at this, what you're seeing here is probably a little bit more than you would have anticipated. So if I look down in my sample class, I see that I have a my method, but I don't see anything else here. But what wound up happening is I got a lot more methods than I may have anticipated. And this is one of those things where it's kind of interesting, especially when it comes to the first two methods, get_name and set_name. I created this name property as an automatic property, and that's one of those syntactical sugar things that C# does for you, that just because you write something in a certain way within C# doesn't mean it has a direct translation into the MSIL code and ultimately what runs within the .NET framework. So one of the things that the compiler does for you when you create an automatic property is to create two methods behind the scenes, a get_name and a set_name, to handle the getting and setting of that property. So then I see the third one is my method, which I would anticipate would be exactly what I thought it would be. But then I also get the toString equals get hashcode and get type methods, but I don't see those. Where are those coming from? Well, those are coming from the inheritance that is inherently built into all classes within the C# language. When you create any class, it will by default, whether you specify it or not, inherit from the object class, which is the absolute base of everything. And I will show you that here simply by appending a little bit extra to our type here, and we'll say base type, and I will type type.base type. So if I do that, Control F5, I'll see now that everything, both of my types program, both have a base type of system.object. And if I take a look in the object browser that you can get to via View, Object Browser, or the keyboard shortcut Control WJ, if I take a look at my console application and I expand this all the way down, I see my program, I see my sample, and I see base types in both of them equating to object. And as you can see in here, we're seeing equals, get hashcode, get type, and to string. So very interesting how that works. I hope you're starting to see how this reflection concept can be very powerful. It allows you to dynamically dig through your own characteristics or your code's own characteristics to do interesting things with them. Now you do have to understand that every single time you do one of these calls to get fields or get methods or get me the executing assembly, you're going to take a slight performance hit because there is some work that the .NET framework has to do to look into itself or look inside these assembly files, because at the end of the day, these things are files, and there has to be some reading done in order to get this information. But for our purposes, this is fairly simple, and we're not really worried about performance, but it's definitely something that you should keep in mind when you're doing this in your code that's going to be running ultimately in production and probably running your business. So yeah, this is interesting, but what's this going to do for me? I can't really do anything with these things. It's just telling me that things exist. Well, on the contrary, you can actually execute things through reflection. So let's take a second to look through that and see what that means. So let's say if I drop down a few lines here, and I decided that I wanted to create a new instance of my sample class. I'll say var sample equal to new sample, and I will initialize my property in my field. We'll give name is equal to John and age is equal to 25. So now I have an actual instance of my sample class, and what could I do to it if I wanted to play around with reflection to get some data out of there, not just what these properties or things might be? Well, you start down the same path as you did before, in that you need to get this type. This is the glue that kind of holds all this reflection stuff together. So I need to get a type. Well, there's two ways you can do that. Both will ultimately take you to the same place, but in slightly different directions. So I can create var sample type, and I can assign it to type of, which is merely just an operator that's going to get the type of a type that you specify within its parameter. This is going to give the sample type a type of sample. You could also do it via the sample.getType method. Both of them will ultimately end in the same way. The only difference is that this getType method is more of a runtime operation, and that you really don't know, or the compiler doesn't really know what you're going to get until you've executed this code. Whereas the type of operator, if I specify sample, is more of a compile time operation where it can tell now, I know specifically I'm running this type of operator to get a type of sample. Ultimately, it's up to you. Use either one you want. I'll stick with this one for simplicity's sake. So now I have that type. Well, just like we started to get the methods or get the properties before, I'm going to do something very similar. So I'm going to get the name property from my sample type, but the way that we do that is via the sample type. Since I have the type, now I want to get a property. I want to get a specific property, not all properties. So let's go ahead and do that. So now it wants a name, and it actually wants the name of the property. And in our case, that is name. Now, you do have to pay attention because C# is case sensitive. Because I named this name with an uppercase N, that is the way I have to specify it within this parameter. If you don't, you will get an error. You won't get an error, but this name property will come back as null. So you just kind of have to watch what you're doing when you're passing in these strings. So now that I have the property, I want to get the value. So let's do a console write line so I can write it out. And we'll say property, and we will concatenate to that the name property, and I want to get its value. But when I ask to get its value, I need to specify the object for which I want to get the name property value from, and in our case, that is sample. So now that we've done that, I can do Control F5 to run, and as you can see here, I found the property, and its value is John. And you can see that based on the helper methods that are found within that type, sample type, I can do the same thing for fields. I could say get field and ask for a specific one. I can get a specific method or members or whatever you want to get. So in this case, one of the things I want to get a little bit closer to towards the end of this lesson, I want to show you about executing methods, because this is where some of the very interesting points of reflection come into play. So let's back up a step here, and I'm going to delete this, and I'm going to put a little code in here just to show you that I'm not faking this. And we're going to console write line hello from my method, and we'll close that off and we'll save. We'll do Control F5, and we don't see that on the screen anywhere. So now what we're going to do is within our reflection code, I'm going to get that particular method. So I want to do var my method is equal to, just like we did before, we're going to go into sample type. We're going to say get method, and we need to specify the name of the method. So we'll say my method, and now we have the method stored within our my method variable, and now I want to execute it. So then to execute this, I'm going to specify my method dot invoke, and now there are a couple parameters that I need to specify. I need to specify the object reference to which I want to execute this method on, and in my case it is sample, and then I need to specify any parameters that need to go into my method. In my case there aren't any, so I can simply say null, I can save, and Control F5, and now you can see I've actually executed my method without directly calling it on my sample instance object. So I see hello from my method. So this is kind of where things start to get a little bit interesting. And as I alluded to on the previous video, when it comes to attributes, you can do even more interesting things with reflection when they're coupled with attributes. So I'm going to take you through kind of an interesting scenario here, one of which I think is very powerful within the concept of reflection and could really help you possibly in the future. So let's take a step back and let's go and create a couple attributes here just to build up this example a little bit. So if you remember from the previous lesson, an attribute is nothing more than a class. So I'm going to create a public class and we'll call this my class attribute. And if you recall, the only thing you have to do in order to make an attribute is make it inherit from the attribute class. In this case, I want to narrow this down to only be able to be applied to the class, and the way we do that is through the attribute usage attribute, and we'll specify the attribute target as a class. So now this attribute can only be applied to a class. So let's go ahead and apply the my class attribute to the sample class, and now I want to create one more that's going to be at the method level. So I'll create a my method attribute, and it's going to inherit from attribute with no implementation. And once again, I want to make sure that my attribute usage is going to restrict this to only be assigned to a method. So now I can save this, and I will apply this attribute to the my method method. So now I can save this, I can build, and everything runs just fine. All right, so now let's use that concept of reflection and assemblies to dig a little bit down into these classes, these types and methods that are found within here via these attributes. So I'm going to get a reference to my assembly. Once again, I'll say assembly.getExecutingAssembly. And now I'm interested in getting types, but I'm not just interested in getting all types. I only want to get the types that are associated or that have the my class attribute associated with them. So let's do this again, var types equal to, or actually better yet, we'll call this my types or sample types. We'll call it types just for simplicity's sake. And now I can say assembly.getTypes, and now that I've done that, I want to specify that I want to get the types where get custom attributes, and that custom attribute that I'm looking for is the my class attribute. So I want to get those where get custom attributes where the count of that is greater than 0, which basically at the end of the day simply means that I want to get all the types within my assembly where there are custom attributes assigned to that type, and not only any custom attribute, but the my class attribute, and as long as there's more than one that's being assigned to that type, I want to get it back. So let's see if I successfully did this. Let's do a console write line. Actually, I have to loop through these first. We'll do a for each var type in types, and I want to do a console write line type dot name. Control F5. So there we go. We did not get program this time like we did last time. We only got sample because it has the my class attribute assigned to it. So now that I've done that, I want to be able to get the method that is associated with the my method attribute. And we'll do that in a similar fashion to how we did before. So once we're in the type that has the my class attribute, now I want to do a var methods equal to type dot get methods. We're going to do very similar to how we did previously. We'll do where, and we can specify where our method dot get custom attributes of the my method attribute, once again where the count is greater than 0. So now I'm going to get all of the methods within the type sample, or within the type that has the my class attribute that has been decorated by the my method attribute, where the count is more than 1, so that we know that it exists on that particular method. So once again, we will do a for each var method methods, and then we'll do a console write line method dot name. So we should only be getting in here, obviously, the my method. And just to make sure that I'm not cheating here, I will create another method in here, public void no attribute method. That's not going to do anything, and I'll rerun this, and you will still only get my method. And you might be saying, well, you're just doing the same thing as you were before. Well, not actually. So as you can see in here, in previous, I was just saying, give me all the properties, or give me all the methods, or things like that. Now I'm assigning attributes to my class and to my methods that allow me to a little bit more generically or declaratively get certain aspects of my code. So this works out extremely well when you want to write some very flexible, some very dynamic code, so that you don't have to say, I want this particular instance, or I want that particular method, I want this particular property. You can now do things, you can decorate things with attributes and allow the reflection to dig in to get those things for you and then execute them. So basically, this really allows some flexibility, some dynamic nature to your code to allow you to be very flexible in adding functionality and being able to dynamically grab certain pieces based on these attributes and execute them whenever you want. So this is a very cool trick. I use this quite a bit, so I would definitely encourage you to play around a little bit more with reflection, and then how it plays around with different aspects of your code, different characteristics, whether it be through attributes or just grabbing those characteristics through specifically looking for certain ones and executing them, or just in general playing around with it, as it is a very cool tool. And if nothing else, it is a very good parlor trick, and it is definitely something that I think you should get familiar with for your usage in development in the future. So I hope you found this very interesting, and I will see you in the next lesson.